Here in this question, they gave a graph, a grid of integers m cross n, which is called image, where image of I comma j represents pixel value of the image. You're also given three integers SR, SC, and color. SR is the row, and SC is the column, and color. You should perform flood fill on the image starting from the pixel image of SR comma SC. This is the starting point of the graph question. To perform flood fill, consider the starting pixel plus any pixel connected four directionally to the starting pixel of the same color as starting pixel plus any pixel connected four directionally to those pixels and so on. Replace the color of all aforementioned pixels with color. So basically, they gave us the grid. Let us see with the example. They said they're giving a grid of an image containing pixels, and they're giving us the starting element cell of the grid from where we have to flood fill. We have to fill the spread across the grid where the start only four directionally. That means up or down or either sides. Then you can only fill, you have to fill the cells with the given color, which is given in the question. You can only fill the color if the adjacent cells have the same color as the starting cell. For example, in this, the starting cell is this one. Here the color is 1 and the color we're supposed to fill is 2. So we can only fill the cells adjacent to it which have the color 1. So we cannot fill 0 or this 0 because it's not 1. So first the adjacent cells are 1 and this one. So we fill it as 2 and then these two and this one. So by now you might have guessed that it's a BFS question. We can also do it with DFS, BFS or DFS. Because in BFS it's level order. First these two get filled and these two and then these two. In DFS it goes like first this or then this, then this, then this, right? Yeah. The second test case is where this is tricky one. We must uh, take this into consideration while solving. Here they gave complete zeros as the image, uh, row number as 0, column as 0, and color also as 0. So here they're saying the starting pixel is already colored 0. So no changes are made in the image. So if the starting pixel is same color as the given color, then we can directly return the graph. Right. So let's start coding for this question. My approach, I'm using BFS for this to solve. Right, let's start. So first, as we have seen in the second test case, if the given color is same as the uh, color of the starting node, then we directly return the image. First, let's take n, length of image, m as then for BFS we use Q, right? So let's initialize the Q. Now, uh, let's just finish the first base case, like the first trivial one. Let's eliminate that one. If the image of SR and SC starting node, if it's equal to the given color, we just directly return image. Next. Uh, Here, let's append the first starting one. Next, I'm taking P color as the uh, present color of the uh, since we are only appending we are only changing the color of the nodes which have the color same as the starting node. So I'm storing it into a variable which is P color. Right. Next. So let's just write the code for BFS. While Q, here call is color. If image, now we have to traverse the like we have to traverse in the BFS in all the four directions, right? Up and the sideways. So to make that easier, I'm taking two arrays of dimensions so that it's easy for the traversal. 0, and I'm taking dcall equals to -1, 0, 1, and 0. So now uh, now I'm changing the current node's color to the given color that we are supposed to change. And then I'm exploring the neighbors. So for that, I'm writing a for loop for I in range 4, since there are four dimensions. I mean, four directions. So the new row will be row plus D row of I. So D row of I is 0. And D call of I is -1. So it will change, like it will explore all the four possibilities for us of row and column. Now we are checking all if new row and new column are in the range that we want, and if the color of the uh, a new row and new column cell is the one that we want. Like here, if it's only one, then only we can change it. If it is 0, we cannot change it, right? So that condition, we are writing it here. If n row is greater than equal to 0 and n row is less than n and n call is greater than equal to 0 and n call is less than n and image of n row and n call is equal to the present color, the color that we want, the color of the starting node. Only then we change the color. Uh, I'm adding it to the queue. And then I'm changing the color. After this, we just return the image. Let's see. It has passed both the test cases.